back to the regular recording type next time. All right, so what we're going to do now is to show the axis of rotation. Okay, so we're going to set up a construct that gives us a visual cue to where the north and south pole is at any point in the year. Okay, so this part is a little more representational than it is practical, but it's important to really see. And you'll get to understand a little bit more about vectors in the interim. Okay, so what we have is a rotated plane. That rotated plane, again, has three axes, but now these three axes have all been rotated. So while the y-axis is currently in the same orientation and position, the x-axis has dipped down 23.45 degrees, and the z-axis has tilted over 23.45 degrees. So there are a few ways of doing this to show the z-axis visually, but what I'm going to show you is just one simple way. At least I think it's simple. But anyway, what we're going to do is take a point and move it out on the z-axis in either direction. Okay, so like you see on the board here, this now is our z-axis because our plane exists through the center point of the Earth. Okay, so our z-axis is going that way. So we're going to go out and create a point, and then go out the other way and create a point there, and actually draw a line between the two so that we can physically see the axis of rotation of the Earth. And that looks like this. To do that, we need to further deconstruct, right? So we're literally cycling through this really fast in this case. We are deconstructing the newly rotated plane. So we go back up into vector, plane, and deconstruct plane. And you plug in the G output is where the geometry is coming from, the rotated geometry. Just another side note that's kind of interesting to be aware of is that not only does the rotate function give you the newly rotated geometry, but if you have other geometry that needs to follow suit, it also gives you a transform, where it basically passes through the command for you. And it says one locally defined value, rotate 23.45 degrees about y, which is pretty cool and pretty useful when you've got a lot of geometry that you have to rotate around a very similar axis. So that's a side note. Anyway, the geometry is what we want to deconstruct. So we plug that in. And then here's the key, right? To create a line, there are a few ways of doing it. Right now, I'm going to go up into curve, and I want to do this sort of the simplest way I think I can find. And I'm looking at the line command. The line command requires 2 points. And if I think about this in terms of the data and what information I have axes, I have a point at the center, I need to create 2 points along those axes. So it's probably easy to just move the point from the center out. And similarly, I can use just a negative and move the other one the opposite direction. Okay, that's part of the cool thing I think about Grasshopper is since it doesn't delete information, that center point always exists. So I can go back to it over here. Where is that? I think I need to pull a point off of it. I can go back to that, and I can do many things with old information. Now, move is under transform as well. It's also under Euclidean, and it's right here. It's move. And the cool thing is that it says it moves an object along a vector. So if I have a plane and I can deconstruct it into the vectors, then I can very easily just move that point out along that vector a certain distance. Now, I want you to look at move carefully. Move has two inputs. It has geometry and it has translation vector. Something you should be aware of is that a vector, I won't go so far as to say always has two components, but it pretty much will. At least for our purposes, you should assume that this vector always has two components. Those two components are an orientation and distance, or direction and magnitude, which are the terms that you would be used to had you taken physics yet or anything like that. Okay, so direction, magnitude. Very, very important to remember that, because you need to tell it where to go and you need to tell it how far to go. Okay, so when we get to it, what we're going to do is we're going to move along the z-axis, which you don't see here. So I take this z and I plug that in.
The geometry?
Yeah. Oh, sorry, no. I'm sorry. What am I thinking of? No. So wrong. Let me go back. I was like twisted in my head. So the geometry is what I want, and you plug in the original point right here. Okay, the original point is the center point of the Earth. Oh no, that's the plane. Let me get a point from it. The origin point, like that. All right, so the origin point right now is defaulting to going straight up in the air. That's not what we want. We want it to go along the z-axis, which is going to put it out this way. So there's this really cool component that's called Amplify that allows us to borrow a direction from something we've deconstructed. So we borrow the z-axis, which right now has no distance. This only has direction. And it will allow us under the vector menu, or sorry, vector tab, vector panel. We do this one here called Amplitude. And its output is a resulting vector, but its input, it requires a base vector, the direction, and it requires an amplitude length or value, and that's the magnitude or distance. So our base vector in this case is going to be z. And if I plug that in now, you'll see that it moved up to where the North Pole is. Yeah, it's hard to see on that screen, but I think you get the idea. And then we just basically put on a slider for how far it's going to go, right? We override what the magnitude is. So I'll put in a slider from 0 to, say, 10. Okay, so 0 is at the origin, 1 is a little bit out, and there it goes, emanating from the origin of our planet. Pretty simple, right? Not too, crazy, too hard to understand.
That water's just a slider, right?
Yeah, it's a slider. Yeah. Okay. So that's one of the points. I want to pause real quick to get you guys caught up to this point before I move on to creating the other point, which is really simple, but yeah. All right, so this is the North Pole axial anchor point, I'll call it. But we need to create one on the opposite side. And so remember that Grasshopper does our math pretty much for us. We don't have to really do much except call things by certain formulas. So if I want to make one on the other side, I can basically, and I'm going to pull this off this way for a second, go into Math and Operators. Go to this one called Negative. Basically, all that does is it takes a numerical value, like the 4, and it makes it a negative. So it'll take 4 as an input, right? So see, that's going to read 4. And then on the output there, it's just negative 4.
Wow. Wait, what standard is
So that, we can plug that also, we can add it as an amplitude, and then that's going to feed back into the move. That's one option we have. So if I hold shift and I plug it into amplitude, all that did was just duplicate the same displacement in the opposite direction along that axis. But here's the tough part. If I want to create a line, I go to curve and primitive, and I select this one right here. It's just line. It asks me for the start point and the end point as separate entities. So there are ways of breaking apart this list of points now. So now this is your first time actually looking at a list, guys. So it's important to note this, and it might actually take a little more explanation when we get into things later on. But this is a list. This list now has two elements in it. I don't recall how much I went into this on Tuesday, but there are two elements in this, right? 2 points. We can break those apart and select them individually, but because there are only 2 points, I don't really have to think too much about it if I just copy the move and connect the opposite angle. So what I'm going to do instead of just adding the negative and having 2 inputs to amplitude, I'm going to, well, actually I need that, but let me disconnect that. And I'm going to have move and amplitude duplicated. And I'll disconnect the number slider. So now I've got one that's being moved in the negative direction and one that's being moved in the positive direction. Okay, so I'll redo that real fast so you guys can see it because it was kind of quick. Okay, so I disconnected the negative. I take move and amplitude, copy, paste. Move it up. Now, the only thing I'm going to need to do is replace the amplitude of what I just copied, right? Because the first one goes +4, and I'm going to make the second one go -4. So I can disconnect that. Actually, I think I could just override it. There you go. Okay, so now to finish off the thought here, and then I'll come help you guys get caught up on it, I have a point that I moved all the way down, and I have a point that I moved all the way up. And those outputs here, right, they're a geometry output. That geometry right now happens to be a point. So I can use my line to connect the start point here to the end point here.
The line is under curve, right? Okay.
Curve primitive. Okay. So to go a step backwards here before I close this video, right, I completed in my mind 2 ideas here. My first idea was to rotate the plane. So I'm going to box that one out. And my second idea was to create all of this information right here. All of that information specifically relates to generating the axis of rotation for the planet. So that becomes another idea. Is that clear, how I'm operating these ideas? Yes?
How do you make that one negative?
That is under math and operators. Negative.
So it's automatically, once you drop it in, it becomes negative.
Once you plug in a number to it, it turns that number to a negative. Yeah.
Once you plug it in, I thought you did something.
Yeah, that's
No, I hovered over it just to show you, right? Because the left side is the input of 4, and the output of y is -4. Okay, let me get this like that for you so you can all see it.